So now we're going to talk about probability. Before we actually start calculating probabilities, we're just going to talk about some terms and ideas related to probability. So first of all, any activity that's under consideration is called an experiment. So that could be something like rolling a die, flipping a coin, selecting one student from a class. Each experiment can produce a variety of observable results, which we call outcomes. So for example, if the experiment is flipping a coin, the observable results or outcomes could be a head or a tail. If we talk about the experiment of rolling a six-sided die, the outcomes could be the numbers 1 through 6. And if we talk about selecting a student from the class, the outcome could be any one of the students in the class. We only look at activities or experiments that can be repeated, and each time we repeat the experiment, it's called a trial. Now, as far as experiments go, we could have a simple experiment such as flipping one coin or rolling one die. Or we can look at more complex experiments such as flipping 2 coins or rolling 2 dice. When we look at the experiments, how we define or come up with a list of all the outcomes can be different. For example, if we flip 2 coins, one thing we could look at is exactly what turns up on each coin. Now, just so we can make sure that we keep it straight, let's say that the first coin you flip is a quarter and the second you flip is a penny. So maybe we want to see exactly what turns up on each coin, and together those two outcomes make our final outcome. So we could get a tail on the quarter and a tail on the penny, thus giving us the tail. We could get a tail on the quarter with a head on the penny, giving us the tail-head outcome. A head on the quarter with a tail on the penny would be a different outcome, which is why you see it listed here. Or both coins could have come up head-head. However, it's quite possible that maybe we're not interested in exactly what turned up on each coin. Maybe instead we're interested in something like the number of heads, in which case all possible outcomes then would be 0 heads, which we would get from here. We could get 1 head, which would come from these 2 outcomes, or we could get 2 heads, which would come from here. Same thing with rolling 2 dice. It's possible that when we roll 2 dice, we could look at exactly what turns up on each die. So meaning a 1 with a 1, or a 1 on the first die with a 2 on the second die, which is different than a 2 on the first die and a 1 on the second. So we could be looking at all possible combinations of what number turned up on each die paired with what number turned up on the other die. But it's possible to define our outcomes in a different way. Perhaps instead we're interested in the sums. So what was the sum that turned up when both dice were rolled? In which case we would get the possibilities of 2 through 12. 2 being the smallest sum, 12 being the largest possible sum. We could even, instead of looking at the sums or the distinct outcomes, we could be looking at maybe just even odd. The list of all possible outcomes, when we create that list, what we're creating is called our sample space. So the sample space is simply the set of all possible outcomes. That means then that our sample space can be defined in various ways, like we just talked about here and here, or even with the 2 dice. A further example of defining the sample space in a variety of ways could be selecting a card from a standard deck of 52. When we select a card, perhaps we're looking at each of the cards as a unique outcome, which gives us 52 possible outcomes in our sample space. But maybe we're not interested in each card as a unique outcome. Maybe we're just interested in black-red. So the suits that give us black, the suits that give us red. Okay? So we can define our sample space in different ways. Once we have defined our sample space, then we look for an event that we're interested in within that sample space. An event is just a subset or a part of the sample space, which is our whole set. You can kind of think of the sample space as our universe. When we were talking about sets in general in the Venn diagram, our sample space becomes like our universe, and the event becomes one of those sets that we defined within the universe that we denoted with a circle. So when we're talking about events within a sample space, we have to make sure that the event goes along with the sample space we've defined. For example, let's say that we were looking at rolling 2 dice, And we were interested in the sums that turn up on the dice. That's how we're going to define our sample space, thus giving us the sums 2 through 12. One event we might be interested in is the event of rolling an even number. Okay. We might also be interested in the event of rolling a number higher than 9. We could be interested in rolling a sum less than 3. We could be interested in rolling an odd sum. Whatever our event is, it must go along with our sample space. So if I was to say I'm interested in the event of rolling doubles, doubles is something like getting the same digit on both dice. Now that would not be possible to consider given our sample space of the sums. Because if you think about it, rolling a sum of 4, yes, that could have come from rolling a 2 with a 2, which would be considered doubles. But the sum of 4 could have also been generated by a 3 and a 1 or a 1 and a 3. So the event rolling doubles wouldn't be an appropriate event given our sample space. If we wanted to look at the event of rolling doubles, we'd have to define our sample space differently. We'd have to look at the exact outcomes that turned up on each die. So perhaps you can think about another event. If our sample space is the sums, perhaps you can think of another event if our sample space is the sums. I've already given you some examples such as rolling even numbers, rolling odd, rolling a sum higher than 9, or a sum less than 3. In the next video, we're going to look at calculating probabilities, and then we'll look at some properties of probabilities in the video that follows.